All right. Good morning, everybody. How are you? Woo! All right. Our next speaker is going to be discussing the development and support of Nagios plugins for e-sensors. So how about a warm welcome for Arun Ramanathan.
Good morning, and I'm pleased to welcome you to Environment Monitoring with Nagios. Before I proceed further, I would like to thank the user community for web sensor and our products, and a special thanks to Ethan and the Nagios team for supporting us since 2003. It has been a pleasure working with you guys. Thank you. And let's proceed with the presentation. It's Environment Monitoring with Nagios. In this presentation, I would be talking about the list of sensors that are involved in environment monitoring, particularly towards the IT sector, because we have more an IT sector-based crowd. And the methods of data acquisition. People generally wonder how a temperature monitoring is possible with, or a humidity or any other monitoring is possible with a network monitoring software. I talk about the methods how you transport the data from the sensor to the Nagios server, then some of our products, how they evolve based on our customer needs, and some more applications with Nagios, the system architecture, and future goals, what we intend to do. Coming to environment monitoring, these are some of the sensors which I would like to concentrate on, particularly the temperature, humidity, and illumination. When we talk about environment, we are constantly interacting with these parameters or these physical parameters around us, and they influence us to quite an extent, and we don't even realize it. So I'm going to talk about the need for this environment monitoring in the later slides. And if you consider an IT sector, you would have more of temperature, humidity, and illumination, and other electrical energy which are measured. And we are constantly using this in our day-to-day life. But if you consider more an industrial sector, we would have some of the sensors like air quality, level detection, proximity, number of people in the factory going in and out, so on, acoustics and pressure, so on, would be more important. And now I would discuss how to transfer the data from the sensor. Two simple ways, just wired and the wireless methods. The wired methods, when we talk of the serial port, which is the RS-232, better known as the COM port, then RS-433, 432 standards are also there. And the USB is also well known, and Ethernet is something which we all know about and we like it. And the problem with serial port and USB is like they cannot run to a very great length. So that is one of the issue. And Ethernet is already a well-established, it blends into our internet and our complete computer network, so it makes it a lot easy, and I'm going to focus more on the Ethernet-based network sensors. And speaking of wireless, there's a very wide divergence of wireless networks available. So the 433 megahertz like subnetwork access protocol, SNAP, is something which is used in nodes which are deployed in several locations, and they can use to be talked to a central gateway, which would be your Ethernet or a Wi-Fi based gateway. And each node would be collecting temperature, humidity, illumination, or water level, and could be any parameter, maybe analog or digital parameters too. And speaking of Zigbee network, Zigbee is a mesh network, that's the advantage. And when I talk of mesh network, if you want to transfer data from point A to point C, so A being the sensor and C being the Nagios server, what happens is A can directly talk to C through the wireless medium, and Zigbee works at 2.4 gigahertz. Or A can talk to C through B also. So A sends the data and B receives it, and B re-repeats it again and goes to C. So there are many redundant paths for the data transfer. This makes the communication more reliable and reduces error rate. Of course, by doing so, you have better data reliability, but you lose your data speed. You lose efficiency of data speed. So any sensor parameter is going to be like not more than 3 or 4 digits, maybe like 4 kilobytes of data. It wouldn't take much time, much network latency wouldn't be required for this. And 6LoWPAN is something similar to Zigbee. It has the Zigbee base, but it has an IPv6 addressing. That is the basic advantage of 6LoWPAN-based sensors. The advantage with that is in the future we are going to have more of IPv6-based sensors, and So 6LoWPAN would be the way to go if we have to develop some new sensors for the future. And Bluetooth is, we all are familiar with it, and it is merely used for peer-to-peer, any prototyping and test applications you want, just you have one particular place to monitor that would be useful. And with the Wi-Fi, we all love it. We all use it all over, and it's a well-known standard. We use the 82.11b in most of our products because although you may wonder when G and N are there, why we still stick to B, the reason is B takes less power. So if you want a battery-operated application, it holds a better job for if you want to use B. And cellular networks can be used in places where you can't run wires and the Wi-Fi is not available, and remote monitoring is required in certain applications. We had customers who wanted to monitor the traffic going through a bridge or somewhere, and we had to talk to them through these CDMA-based modems. It was just a concept which we provided what could be done. And speaking of our products, what we have, the EMO1 and EMO8 are known as the web sensor. They basically, EMO1B was the first product which we developed, and it proved it well over the years. And it has basically monitors temperature, humidity, and illumination. And we have additional parameters can be monitored by the EMO1. That was one of the reasons why it always made it to the server rooms, because it can monitor thermistor, battery voltage, contact closure, and water flooding too. If you want to configure your EMO1 with Nagios, you would be able to monitor temperature, humidity, and illumination at the sensor end, and you can have a probe attached to it for doing thermistor or battery voltage monitoring. When I speak of battery voltage, it's like monitoring the UPS batteries, which is a DC voltage. So many of you us want to know that none of the UPS systems which were used in the early 2000s had the ability to monitor the voltage and report it to the computer. So that by using this, we could cross-check and see how good the battery is. If it is on load, what's the voltage? Is it dropping? Or things such sort of reports can be generated. Contact closure is another important feature. It does help in certain security-based application. All you have to do is you have to crank up the polling interval for Nagios to keep checking every 10 seconds and see if any contact closure is alert is sent, so that you get an immediate alert as soon as the event occurs. Contact closure is basically you have some kind of a read switch which is magnetically actuated, and you can have it set up on a door or in a server room. You want to be notified if somebody enters the room or somebody leaves the door open or something. Any contact, it's just an on-off switch which can be actuated, and Nagios can sense it. Water flooding is another important application which many people were interested in. When you have extreme weather conditions and like condensing temperatures, you would have a lot of water condensate form near the AC ducts, and this could really hurt. If it can cause any short circuit, you don't want that to happen in your server room or something, preferably not on a weekend. And when we developed the battery voltage monitor, there were several requests coming to us, like asking us whether we could make something to monitor the AC line, and that's what led us to develop the power meter. We have been developing and researching them for years, and we have finally perfected it, and we have a good design. The power meter PM21 is something which plugs into your wall outlet, and it has the ability to monitor voltage, current, true power, and a lot of other power quality parameters. When I speak of power quality parameters, like in certain European countries, they have certain limitation on the power factor of the load which you're going to use. How much of like lead and lag, the current and the voltage will be in phase or not in phase, depending upon the inductive or a capacitive load. And most of the computer systems use a SMPS-based power supply. It's a switching power supply. That causes a lot of noise into the line. And if you're in an educational institution or in a medical organization, you have these computer systems installed, you don't want to kick in these noise going into these sensitive monitoring equipments. So the power meter helps in monitoring this thing. Even better, it has a built-in relay. So Nagios would no longer be just a monitoring device. If you use it with a power meter, you can use it even to control a load that is turned on or off a device using the power meter. This could be a space heater, could be a table lamp, it could be anything which you can plug into the wall outlet. Then we built the three-phase power meter, which is still in the prototype stage, but we have it working. We have been testing it with Nagios too. It works great. And that monitors the current voltage and these power quality parameters for all the three phases. And both the devices work on worldwide voltages. It works on 50 cycles and 60 cycles. So that makes it a worldwide application possible with these devices, and using Nagios would give you a wide range of flexibility, a wide application range can be addressed to with these devices. And let's go on to the application with Nagios. I can show you in an example how in an office environment what you have installed, what you can automate, and how you can go ahead. And to understand this further, we would need to know something about the device architecture. And most of you guys are from IT here, or some from electronics background would be able to easily understand this. Okay, anyway, I'll make it simple for you. The hardware architecture is pretty simple. It has a sensing element. It would be a temperature sensor in the case of a an EMO1 or a web sensor. It could be a small light sensor IC in the case of light measurement, or a voltage or a current sensing resistor, maybe even a current transformer. The signal conditioning converts these analog and digital voltages into measurable parameters for the microcontroller unit. And that in turn puts the data onto a TCP/IP stack. So moving to the software architecture, the device supports TCP and UDP protocol. The EMO8 has the ability, it's a web sensor which has the ability to even support SNMP and SMTP, so you can send out emails from the device without having to go through a computer application. The reason why we put on this feature is if you have Nagios set up to monitor an SMTP server, and you want to use the same SMTP server to send mails out from this device, you can monitor more mails and from which host is sending the mail and so on. Such applications were done by a few of our users. It's like because the plugin source is open, plugin code is open source, and people are very free to customize it. And over the years, people have done a lot of work with that. And TCP is the usual one way how we use to transfer the data using HTTP request. The device itself doesn't send active alerts or active HTTP data to the Nagios server. The Nagios has to send in a HTTP request, and the device responds back with a HTML buffer carrying the required measured parameter. And the device holds a Wi-Fi or an Ethernet stack depending on which device you want to pick and how you want to configure it. And I'll speak of the applications further right now. So you have a centralized Nagios server in your office, and imagine these are the sensors which are installed in your office. You have the power meter to monitor the power into the UPS. How this would help is monitoring the power into the UPS is when you monitor the current into your UPS, you get to know the nominal load for the UPS, nominal current drawn when your office is fully functional. And if you would be able to set up threshold values in Nagios if you know that you're going beyond few hundreds of amperes, or so you would be able to say, okay, if my power goes down, my UPS would not be able to take that load. So you can have such alerts also set up. And even if the power to the inlet of the UPS is lost, the power meter will read zero current and zero voltage, and that can give a critical high alert and probably send emails to you too. The air quality monitor is another important application which we came up with. It can be configured with several groups of sensors. We had even medical applications coming up to that. Even textile industries wanted to know whether the stock rooms have a good clean air, otherwise clothes could get damaged if there's too much of VOC, volatile organic compounds, in there. So the CO2 monitor in your office is pretty important. If you can measure the amount of CO2 and you find it a little high, that's why you'd probably think you may be running for extra coffee. So the EMO8F is a wireless-based web sensor. It uses the Wi-Fi standards. It mostly finds itself installed in several office rooms and several points to check any cold spots or extra humid spots, make sure how efficient your heating ventilation system is, and to see whether you're making full use of the utility bill that you're paying. All that can be achieved. As I said before, the EMO1B always makes it to the server room. Most of our customers who got EMO1B who are working with Nagios used it in a server room to install because it has an external thermistor probe. They measure the air exhaust outlet from the SMPS of the server and have this set up as a flood sensor too. So check near the air conditioning duct if there's any water smudge forming in the ground, and that can be monitored by the Nagios system too. And the power meter has its ability to control any outlet You can use it for setting up your illumination. You can make the Nagios plugin check the system time, turn on or off the light at a particular time of the day. You can even adjust the heating system, or even use the relay to turn on or off something even bigger, like your HVAC system can go down entirely if you're after your office hours and so on. And I didn't want to show lines of code on the presentation, so I just simplified the plugin as a flowchart. What you have here is just the host IP. The plugin's name is like check PM21. It will be found in the libexe folder of Nagios. And how you run the plugin is like check PM21, then you specify the host IP, the sensor name, then the limits. We've specified 4 limits to the plugin, which I would discuss further when I show the config files. What the plugin actually does is it writes the command to the HTTP socket, reads the data back from the I/O buffer. Then we parse the data from string to floating point and process the data based on the thresholds which we specify. We check with the time and send the alert accordingly, and we also control the relay accordingly. The relay function is not directly built into the one which you get off the stock. You can customize it. We can give you the code too if you request it. And going to the config file definitions, basically you need 3 files to set up a web sensor out of the box. If you have a Nagios system which is running, it could be 32-bit or 64-bit, it still works. This was tested on Linux. The parameters.config file holds the configuration. You can specify a host name, the alias saying that this is in your office room, this is in your cubicle, and so on. And this holds basically the IP address of the device. You can even specify a port number in the plugin if you want. You can use the command check PM21, and the 4 values which are given here, 100, 520, and 1000, which you see here where I'm pointing. Those are the thresholds which are specified. You can change it based on your requirement. And this service is for the true power. Each parameter measured by a device is considered as a separate service and listed under a host. So how it works is like any value between 100 and 500 is considered as status OK. And anything between 120 is considered as warning low threshold, and anything between 500 and 1000 watts would be considered like a warning high threshold. Anything above 1000 watts is something like an overload, so it would consider it as critical high, and anything below 20 is something wrong. Probably the device is not even turned on, the UPS isn't taking enough power or something, so it would be considered a critical low threshold, so on. The eSensors config file stores the command line parameter, how it's specified, and all the command lines for all the services listed together. So basically you would have to only modify the parameters.config file to get it running with Nagios. This is how it goes. This is a screenshot of the host list. The parameter and the web sensor are used in Nagios, and this is how you see them. You have a lot of services, and this kind of causes poll delay. So you could comment out any service which you don't need to use. You may not need to use all the services. Truly speaking, the parameter has the ability to report 20 different measurements to the Nagios server. So many people ask a question: if you use the parameter, if there's a sudden voltage spike, wouldn't Nagios miss it? Because Nagios only talks to the device every minute or every 10 seconds or however he specified. Yes, we address the problem. We have a separate variable or a separate measurement like true high and like the daily peak value, and all can be added on to this. So that is how we keep track of past reading and makes Nagios know that peak has occurred at some point of time. And you can see the warning alerts also displayed, and this is how the warning is also shown between, okay, we have a temperature warning here, which is between like 94 Fahrenheit. Probably the heating is the cooling system is not working so well, or that part of the room is pretty hot, so on. Now I'd like to speak about some advantages of this device. The main advantage which we try to aim at is to integrate it into your existing network system. Many utility buildings and other companies or an organization who report to us, first question they came up with is whether do we have to lay extra lines? Do we have to build a separate infrastructure for this device? The answer is no. It just integrates into your Ethernet system and so on. So it makes it a lot easier to install and maintain this device. It extends the monitoring capability of Nagios, and in fact makes Nagios even possible for control applications in the future. You can make Nagios run a script which would in turn turn on or off a device. You can even modify a similar script for some other application of yours to turn on or off a particular service running in your computer. You could even do such applications with this. And it also prevents server crashes due to external conditions like extreme humidity or heating or other kind of possibilities or hazards which can come over. And you can optimize your energy consumption. When you keep, it doesn't directly reduce the amount of power which you take. When I say this, I have to be careful because it makes you aware that how much you're consuming every day. So when someone keeps measuring their weight every day, they get a little cautious, like you shouldn't eat much. So that's the same technique how these monitoring systems work. In fact, any monitoring system works the same way. And I would like to go to some future goals which we intend to do in the future. We want to integrate it with the HVAC systems, that are heating, ventilation, and air conditioning systems, the fire security, and building utilities. So if anything goes wrong, you have a centralized Nagios server to which it gets reported to, and you also get notified. The information is passed to the utility company, and even billing would be possible. This would be similar to how smart metering concepts can be developed. And we use the advantage of the computer network for modern instrumentation by doing so. And by deploying smart sensors at home, you can see how efficiently you're managing your budget, and you can see how whether the bill that you pay for is really worth it, or whether you're paying extra and you're not getting warmed up in winter so much. And you can also monitor your resource utilization, so on. And by seeing the statistical data reported, what we intend to do is provide more deviation and trend prediction in the device itself. So by doing this, you don't have to modify anything in Nagios. The device would add an extra measurement, which would say, like, today, okay, the trend is going up and the trend is going down on the particular day of a week. So that would tell you how well you're performing over time, and that would help you even manage budgets better. And with this, I conclude. You have any questions? Yep.
You said you supported IPv6 over a wireless, one of the protocols. Do you also support IPv6 over the Ethernet protocol as well?
That is not in our current devices, which we have. The current ones which we are concentrating on is based on IPv4 only. In future, we have we can upgrade to IPv6. That's what we are planning to do to address the future. We do have devices which have 6-low-band addressing. It's still in the prototype stage. I just mentioned that slide to show what all are the RF methods of communication.
Are any of your Ethernet-connected sensors capable of being Ethernet-powered as well?
We are currently actually working on it, but not right now. We did have that power over Ethernet-based devices, and we had a lot of issues with that because of misuse of the device. So we had to put in more protection into the device, because when someone plugs into the device, they should make sure they have the right voltage in the device, and they should plug it into the right kind of PoE-based router. And we are working. What we do at the moment is customers who request us for PoE-based application, we sell them and bundle them in off-the-shelf module along with it. So that addresses the issue.
Did we have any other questions? All right, well, let's put our hands together one more time for Arun.
Thank you.